Hello students, good morning, good evening and good night. Welcome to this first video on redox reaction. From this lecture onwards, we will going to discuss different aspects of this chapter in your syllabus, in your chemistry syllabus. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. In the first lecture, we will going to discuss the very important preliminary idea regarding the oxidation and reduction reaction. So let us start with this introduction to this chapter, to this subject, that is redox reaction. Oxidation and reduction reaction is very important nature of reaction. In many biological and industrial process, we will have this found that there is a lot of applications of these reactions. So let us understand what is meant by the oxidation. Oxidation process can be described as in different ways or different manners that we are now going to discuss. First, that is oxidation, we say that is the addition of oxygen. Addition of oxygen, we will say the oxidation reactions. As for example, this is magnesium solid plus oxygen gas. It will going to produce the magnesium oxide. In this case, what is going to happen? Due to, on account of the oxygen is added in the magnesium, we will call the magnesium Mg is oxidized by oxygen. Another reaction that you can see, that is sulfur plus O2 gas, and you will find it is SO2 gas. And here also you can observe that sulfur is oxidized on account that oxygen has been added to it. So you can write here sulfur is oxidized by O2. This is the one way of seeing the oxidation reactions. Second, the addition of electronegative element. Electronegative element. As for example, that is magnesium solid with the chlorine gas, it will produce magnesium chloride solid. Here you can say magnesium is oxidized because due to the addition of the electronegative element, that is chlorine. So we can say here magnesium is oxidized. Another reaction we can see, magnesium plus fluorine. Here you can see it will produce magnesium chloride solid, and it is also, you can see that fluorine is the electronegative element. It is attached with the magnesium. That is why magnesium solid is oxidized. So we understand the addition of oxygen and addition of electronegative elements, both we will say the oxidation reaction. Third, the removal of hydrogen. Removal of hydrogen, that will be also be considered as a oxidation reaction, like H2S gas plus O2, it will produce sulfur solid plus H2. So here you can see the hydrogen has been replaced from H2S, and that is why we will say that H2S is oxidized, because there is a removal of hydrogen. So here you can say that H2S is oxidized. Why it is oxidized? Because hydrogen is removed from here. Okay, then fourth point, that removal of electropositive element. This is also we will call the oxidation reaction. Here also you can see the removal of electropositive element. Here electropositive element is potassium, and it is removed and it will produce the KOH, and that is why we can say, and it is formed this is a ferrocyanide, and it is produce the ferricyanide. Potassium ferrocyanide has been converted, has been produced the potassium ferricyanide, and this will, here you can see the potassium has been removed from this potassium ferrocyanide, and that is why we call this is it is oxidized. It is oxidized by H2O2. So we can see the removal of electropositive element is also a oxidation reaction. So we can make a summary of this oxidation reaction like this. So we can summary of all these 4 exercises. We can make a summary of the oxidation. How do we define oxidation? Now it is the addition of oxygen. It is the addition of electronegative element. It is the addition, it is a removal of hydrogen, and it is the removal of electropositive element. This is what we can say as oxidation. So oxidation, there is a 4 things happen. It will add, when there will be addition of oxygen to the substance, then we will call it oxidation. When the addition of electronegative element to any other substance, we will call it oxidation. When there is a removal of hydrogen from the substance, we will call it is a reduction. When there is a removal of electropositive element, we will call it a reduction. So these are 4 ways that you can able to define the oxidation. We will discuss the reduction. Likewise, in the oxidation process, reduction can also be defined in several ways. First, that is the removal of oxygen. Removal of oxygen. This example we can take mercury oxide. When mercury oxide has been heated, it will going to produce mercury and oxygen. When mercury oxide is heated, it will produce the mercury liquid and oxygen gas. In this case, we will call the mercury oxide is reduced. It is reduced because of removal of oxygen. Okay. Now, second is removal of electronegative element. When there is removal of electronegative element, we will call it is a reduction process. Example: very quiet, we react with hydrogen, it will produce the ferrous chloride, aqueous, and HCl. So, what is there? It is the removal of electronegative element. Here you can see ferric chloride reacted with the hydrogen gas and it will produce the ferrous chloride, aqueous, and the HCl aqueous. And at that time you will find here is the removal of the electronegative element chlorine from the FeCl3. So we will call it is a oxidation reduction reaction. This is the reduction reaction because removal of electronegative element. Third, the addition of hydrogen. Addition of hydrogen, as for example, this is ethane gas, and when it is being reacted with hydrogen gas, it will produce ethane gas. This is ethane gas, and when reacted with hydrogen, it will become the ethane gas, C2H6. And this is also we will call the reduction reaction. This is reduction reaction because of there is a addition of hydrogen is there. Number 4, the addition of electropositive element. Electropositive element. So this is, again you can see, this is the addition of electropositive element. Here in the mercury chloride there is an addition of the mercury and it will produce the Ag2Cl2 in the solid state, and stannous chloride. From the stannous chloride which will produce the stannic chloride. Here AgCl2 has been reduced because there is an addition of the electropositive element. So we can categorize, we can define the electronegativity reduction in the 4 different ways. Number 1, that is removal of oxygen. Removal of oxygen, number 1. Number 2, removal. So reduction is again can be explained, can be defined in 4 different ways. That's the removal of oxygen, number 1. Number 2, the removal of the electronegative element. Number 3, the addition of hydrogen. And number 4, the addition of the electropositive element. Okay, so we understand what is oxidation and what is reduction. Now, one thing you can see, you can observe from this reaction, you can see, if you specifically understand, if you basically see, that here you can see there is a addition of the Ag, that is electropositive element. That is why this you can see has been reduced. This is reduced. At the same time, you can see the stannous chloride. There is addition of chlorine that it will produce the stannic chloride. And here you can see from our definition, it is reduced. It is oxidized. So this is oxidized, HNCl2 is oxidized due to the inclusion of the electronegative element. At the same time, the AgCl2 is reduced due to the inclusion of the electropositive element. So both way you can see there is a oxidation, here is a oxidation, and here you can see the reduction is going on. That is why we will now understand that is why a reaction can be called, this type of reaction is called the redox reaction, because simultaneously there is a oxidation and also the reduction reaction is going on. That we will now discuss with some examples. Redox reaction is those reaction in which we can say it is such reaction where reduction and oxidation occur at the same time. This is called the redox reaction. The example already we have observed previously, when stannous chloride is react with the mercury chloride. After that it will produce the Ag2Cl2 and stannic chloride. There you can observe the reduction and oxidation both has been carried out simultaneously. To understand the reduction reaction, let us first understand this reaction. Now let us analyze this reaction. Sodium has been reacted, sodium solid and gas, and it is produced the solid. When it is reacted, what we found? We find that if we go with the traditional concept of reduction, we will see that sodium is reduced because it has been added with a hydrogen, right? So if we make a conclusion like this, it will be a erroneous conclusion. This is not the correct thing. So let us understand this in type on the different ways. We have to understand this reaction in different ways, and that is how we can able to predict correctly about this reaction, which is oxidized or which is reduced. And for that, let us take an example of this. See, these two type of reaction, you can easily predict one thing very clearly, that here as sodium is added to a electronegative element, so we can say sodium is oxidized to NaCl. Sodium is oxidized to NaCl. We can say easily because it is been added to the electronegative element chlorine, and at the same time chlorine is added to the electropositive element, so we can say chlorine is reduced because it is attached to the electropositive element sodium. So this reaction we can see both the oxidation reactions and reduction reaction is going on simultaneously, and that is why it is called the redox reaction. Redox, RED, reduction. Words come from the oxidation. We take the abbreviation from the initial words. It is called the redox reaction. Here you can see the Na plus chlorine gas. When reacted to produce the NaCl, it will be a redox reaction. In the similar way, you can see nice sodium is reacted with oxygen, means there is addition of electronegative element oxygen with the sodium. That is why you can say sodium is oxidized. At the same time, oxygen is reduced because it is added to the electropositive element. So we can understand from these things. Now we can easily able to understand this, that we have to analyze this reaction on the light of the electropositive or electronegativity of the element. So here hydrogen is less electropositive, we can consider, as compared to the sodium, it is electronegative, whereas sodium is electropositive. So here hydrogen is reacted with this sodium, that means sodium is oxidized. So we can write this, sodium is oxidized because it is being oxidized because it is being added to the electronegative element hydrogen, and at the same time hydrogen is the electronegative element and it is being attached to the sodium. So we can say hydrogen is reduced. So in this reaction we can understand the hydrogen is reduced, sodium is oxidized on the basis of the electronegativity. So we have understood in this lecture the very important fact, what do we mean by the oxidation, what do we mean by the reduction, and there is several ways that we can able to understand the oxidation process and the reduction process. And we understand also the redox reaction, that is reduction and oxidation both are being occurred simultaneously. And how do we able to see some of the reaction like this? At that time we have to consider the electronegativity. And that is all for today's lecture. In next lecture we will go to the relationship between the oxidation and reduction with the electron transfer system. How electron transfer system going to influence the oxidation and the reduction, that we will discuss in the next lecture. That is all for today's lecture. Thank you very much. If you like this lecture, you can share to your friends. Thank you very much for watching.